Lesson A6 is on equivalent expressions. Equivalent expressions are expressions that when you plug in a number for x, you get the exact same solution. So the question here is 2x plus 6 equivalent to 2 times the quantity of x plus 3? Now they look different right away, but one thing that we can remember from lesson A3 is the distributive property. There's nothing more that we can do with 2x plus 6. It's in its simplest form. But with the second expression, we could say that 2 wanted into the party, so 2 had to shake hands with the x, and then the 2 had to shake hands with the 3. 2 times x is 2x, and 2 times 3 is 6. So in this case, we, for both of them, got 2x plus 6. Another way we could look at it is I could take my 2x plus 6, and I could take my 2 times my quantity of x plus 3, and I could start plugging in numbers for x. If I plug in 1, I have 2 times 1 plus 6, which is 2 plus 6, which is 8. If I come over here and plug in 1, 2 times the quantity of 1 plus 3, or 2 times 4, because we have to do parentheses first, which gives us 8. It's not enough to just test one number, so you want to test a couple, maybe one positive, the number 0, and one negative. So here I could plug in 2 times 0 plus 6, and I'm going to get 0 plus 6, which is 6. If I plug in 0 here, I have 2 times 0 plus 3, or 2 times 3, and I get 6. So far, both of the expressions are giving me the exact same answers. I'm going to try a negative number, so 2 times negative 1 plus 6. 2 times negative 1 is negative 2, plus 6 is going to give me 4. On the next one, we've got 2 times negative 1 plus 3. Negative 1 plus 3 is 2, and 2 times 2 gives us 4. So in this case, I would say that yes, these are equivalent expressions. This table is basically showing you exactly what I just did on the last page, but it's giving you a broader range. We're going to plug in these specific numbers, and there isn't any special reason why we chose these numbers to plug in. It just gives us a good example of positives and negatives. So here we're going to plug in 2 times, instead of x, 2 plus 6. Here we'll do 2 times 1 plus 6, 2 times 0 plus 6, 2 times negative 1 plus 6, 2 times negative 2 plus 6. And we'll solve. 4 plus 6 is 10, 2 plus 6 is 8, 0 plus 6 is 6, negative 2 plus 6 is 4, and you'll notice there's a pattern, so the next one should be 2, but 2 times negative 2 is negative 4 plus 6 is 2. We'll plug in on the next one. 2 times 2 plus 3, 2 times 1 plus 3, 2 times 0 plus 3, 2 times negative 1 plus 3, and 2 times negative 2 plus 3. 2 times 5 gives us 10, 2 times 4 gives us 8, 2 times 3 gives us 6, 2 times 2 gives us 4, 2 times 1 gives us 2. And if you notice, 10 matches 10, 8 with 8, 6 with 6, 4 with 4, 2 with 2. So yes, these are equivalent expressions. The next one's asking us, is 4 minus x plus 2 equivalent to 4 minus the quantity of x plus 2? So one thing we could do is we could simplify the expressions. The only different thing on these, like this first one, there's nothing we can simplify because we can't combine the 4 and the x. We can leave those in parentheses. When you see that there's this minus sign outside of a parentheses, we can remember the distributive property. It's as if you're distributing a negative 1 to everything inside. So it would be 4, and then the negative 1 shakes hands with the x, and then the negative 1 shakes hands with the 2. So that would give us 4 minus x, or plus negative x, plus negative 2, which would be 2 plus negative x. This one, if we undid the parentheses, because we've already solved that, we would have 6 minus x, and these two do not give us the exact same solutions. On the next page, we're going to start plugging in numbers to see if these expressions give us the same answers. So for the first one, I'm going to plug in 4 minus 2 plus 2, 4 minus 1 plus 2, 4 minus 0 plus 2, 4 minus negative 1 plus 2, 4 minus negative 2 plus 2. And we have to figure out what they equal. So 2 plus 2 is 4, 3 plus 2 is 5, 4 plus 2, 6, keep it, change it, flip it, 5 plus 2, 7, keep it, change it, flip it, 6 plus 2, 8. Now we have to try the next one. So we've got 4 minus 2 plus 2, 4 minus 1 plus 2, 4 minus 0 plus 2, 4 minus negative 1 plus 2, 4 minus negative 2 plus 2. So 4 minus, that's 4, so we have 0. 4 minus 3 is 1. 4 minus 2 is 2. 4 minus 1 is 3. And 4 minus 0 is 4. And if you notice, our answers don't match. So 4 does not match 0, 5 does not match 1, so these two would not be equivalent expressions. The next one that we're wondering is 3 times x times 4 the same as 3 times x times 4? If we look at this, we'd have to multiply the 3x first. 3 times x is 3x, and then we'd have to multiply by 4, which would give us 12x. Here we would have 3 times x times 4 is 4x, which would also give us 12x. So when we simplify the expressions, we see that they should be equivalent. But we'll go to the next page to test and see if they're equivalent. So we have 3 times 2 times 4, 3 times 1 times 4, 3 times 0 times 4, 3 times negative 1 times 4, 3 times negative 2 times 4. 3 times 2 is 6, times 4 is 24. 3 times 1 is 3, times 4 is 12. 3 times 0 is 0, times 4 is 4. 3 times negative 1 is negative 3, times 4 is negative 12. 3 times negative 2 is negative 6, times 4 is negative 24. Do the next one. We have 3 times 2 times 4. We have 3 times 1 times 4. We have 3 times 0 times 4, 3 times negative 1 times 4, and 3 times negative 2 times 4. 2 times 4 is 6 times, try again. 2 times 4 is 8, times 3 is 24, which matches. 1 times 4 is 4, times 3 is 12, which matches. 0 times 4 is 0. Times 3 is 3, or is... Okay, Miss Sullivan, like 0 times 4 is not 4, it's 0. And 0 times 3 is not 3, it's 0. I'm sorry, it's 6:45 in the morning, and I'm a little tired right now. I apologize. Sorry for any confusion. So here we've got negative 1 times 4 is negative 4, times 3 is negative 12, negative 2 times 4 is negative 8, times 3 is negative 24. So they do all match. I'm just having a little brain fart this morning. Bear with me. What can determine equivalence using algebraic properties and tables? What might be a limitation when using tables? Something that you want to consider when you're using tables is if you don't test the appropriate types of numbers, you might think that they're equal, when in reality they're not. For example, if we have here and we're only testing the numbers 0, positive 1, positive 2, and positive 3, we might think that everything is equal. So we have 10 plus the absolute value of 0. Absolute value of 0 is 0 plus 10 is 10. We have 10 plus the absolute value of 1. 1 plus 10 is 11. 10 plus the absolute value of 2. 2 plus 10 is 12. 10 plus the absolute value of 3, which give us 13. Come over here, we'd have 10 plus 0, which is 10. 10 plus 1, which is 11. 10 plus 2, which is 12. And 10 plus 3, which is 13. Right now, these these expressions look like they are equivalent. If you could think of a number to test that might change that, you want to think about our absolute value. Absolute value affects negative numbers, and we didn't test any negative numbers. So if I were to try to test a negative 1, we'd have 10 plus the absolute value of negative 1, which would give us 1 plus 10, which is 11. But if I came over here and I added 10 plus negative 1, I wouldn't get 11, I would get 9. So in this case they should not be, but the numbers that I chose to test with showed me that they were equivalent. So you have to be really careful with the numbers you choose to test. I'm not sure why that slide's on there twice. Okay, so we want to check these ones to see if they're equivalent. Here we have 5 minus 5, 5 minus 3, 5 minus 0, 5 minus negative 2, and 5 minus negative 4. So we get 0, 2, 5, keep it, change it, flip it, 7, keep it, change it, flip it, 9. We'll try the other way around. 5 minus 5, 3 minus 5, 0 minus 5, 0 minus 2. No, sorry, let me erase that. Good thing I don't teach algebra this early in the morning. I'm just kidding. We've got negative 2 minus 5, and we've got negative 4 minus 5. 5 minus 5 gives us 0. So far, so good. 3 minus 5, we have to keep it, change it, flip it. 3 plus negative 5 is negative 2. Are 2 and negative 2 the same number? You should say no, they are the opposites. 0 minus 5, or 0 plus negative 5, is going to give us negative 5. So what I'm noticing is that we're developing opposites here. 7, negative 7. 9, negative 9. So these would not be equivalent expressions because they give you the opposites. So circle all of the expressions below that are equivalent to 8x minus 6. Let's break them down. So for this one, we have 5x minus negative 3x minus the quantity of 2 plus 4, which breaks down to 5x minus negative 3x minus 6. Keep it, change it, flip it. We get 8x minus 6. So this one is equivalent to this one. 2x, what I think somebody did was they took 8x, they subtracted 6, and they had 8 clips, and they took away 6 pencils and said they had 2 clips left, which is not the case. This one we have to distribute. Negative 2 has to shake hands with negative 4x, plus negative 2 has to shake hands with a 3. So we get 8x plus negative 6. 8x plus negative 6 is the exact same as 8x minus 6, so they are the same. Here we have 8x because the 2 shook hands with the 4x. And when the 2 shakes hands with the 3, we get minus 6. So this one also is the same. Here, we've got negative 2 times negative 4x and a minus negative 2 times 3. So we get positive 8x minus negative 6 or plus a positive 6. This one is not the same. Over here, remember the other day I said we could simplify fractions? We could say that meant 16x over 2 minus 12 over 2. You can break it up into 2 separate parts. 16x over 2 is 8x, minus 12 over 2 is 6. So this one is also equivalent. Create 2 different expressions. One thing that I could do here is I see this minus right outside the parentheses, and the minus could want to join the party. I'm going to make it a minus 1. So this could be 10 minus when the minus 1 shakes hands with the 5x, that'd be a minus 5x. And when the minus 1 shakes hands with the minus 15, you get a positive 15. Another way to write that, I could combine my like terms. 10 plus 15 gives me 25, and I still have that minus 5x. The next one, there's really nothing that I can combine on this one, but I want you to know that order does not matter. So I could write this as b plus 12a minus 4, or I could write minus 4 plus b plus 12a, and it would still mean the exact same thing. Okay, so we want to show and explain why 8x is not equivalent to 7. So some people assume that because I have 8 x's, I take away 1 x. I've taken away 1, which gives me the 7, and I had an x, but I took it away, which gave me 7. The reason that's not the case is if I had 1, 2, 3, 4, 5, 6, 7, 8 x's, and I took away one of those x's, so this one's gone, you have to see what you have left. How many x's do we have left? We have actually 7 x's. So we haven't got rid of all the x's, we only got rid of 1. Write an expression for the area of the figure by breaking it into non-overlapping rectangles. So what I'm going to do is I'm going to put a line right here. Going to put a line right here because I know that if this section right here is 3 and the whole section is 5, then this has to be a 2. So I'm going to cross this off because I don't need it anymore. And I know this would be a 2. Go like this. So here I can get, this would be a 3 right here if that whole thing is 5. So this is a 3 by x, or 3 times x, which gives us 3x. Here for this section we have 2 times 6, which gives us 12. Here we have 2 by x, so that would give us 2x. Here we have 3 times x, so that will give us 3x. But in the end, we need to add all of our like terms together. So we have 3x plus 12 plus 2x plus 3x. Our like terms are 3x plus 2x plus 3x. So we have 5, 6, 7, 8 x's plus we have 12. That would be our final answer. Some of you may choose to break it up a different way, and that's totally okay. If you broke it up a different way, please share with the class how you broke it up. And one more way. So looking for a couple different ways to break this up. Think of one on your own. Again, if you need help with homework, Sullivan A at milton.k12.wi.us. Have a good weekend.